So this is called piecewise functions because we are looking at pieces of functions, all right? So what piecewise functions are, they are functions defined by two or more subfunctions each with its own, oh, that's not the word own, oh my goodness, own domain. Okay, so they are functions defined by two or more subfunctions, each with its own domain. The graphing is the same with this stuff. The functions are the same. The difference is we have boundaries. You're only going to get little slices of them. You don't get to use the whole thing from negative infinity to infinity. So they look like this. Now, I think on your paper it looks better than it does on my board. I don't know why it transfers like this. This is a big bracket, but I'm pretty sure yours looks right. Yeah. So this f of x, where normally we would just have f of x equals one of those things, like one of the three. But we have this big bracket because f of x equals all of them together. But if I literally just graphed all that together and I had an absolute value, a parabola, and a square root, they'd all be kind of overlapping, right? Then it wouldn't be a function. So instead, their domain. Well, I have these different domains. So when x is less than negative 3, so if we think about what's happening on the number line here, like on the graph. So let's say here is negative 3, right? So from anytime x is less than negative 3, then in here, this is where I would have part of my absolute value. Then between negative 3 and 7, in here would be a piece of the quadratic graph. And then everything bigger than 7 over here would be a piece of the square root graph. Does that make sense? It's not the whole thing. It's just like little slices of it depending on the domain. The main part, what we're going to look at is just how to evaluate algebraically and then also how to evaluate graphically. So I want to find f of negative 5. Here's what you don't do. I don't take negative 5 and substitute it in this one, then substitute it in this one, then substitute it in this one. You only substitute it where it goes. If x is negative 5, it's like over here, right? And so that means it's less than negative 3. So when x is negative 5, we're using this graph, so this is the only one we plug it into. Does that make sense? So this is going to be equal to 2 times the absolute value of negative 5 minus 5. So that's 2 times the absolute value of negative 10. What's the absolute value of negative 10? 10. So this is 2 times 10. So f of negative 5 equals 20. Okay. Easy enough? All right, so the next one, f of 2. Does that fall in the domain of the first, second, or third equation, or first, second, or third subfunction? The second, okay, because it is 2. 2 is between negative 3 and 7. You literally look at this right here. And see how this one, negative 3 is not included, but it is included here? So let's say I wanted f of negative 3. I still don't plug them into both. It's 3 is where it would be included here. But 2 falls into here, so this is the one I'm substituting it into. So I'd get negative, and then 2 squared plus 4 times 2. So remember this. Now look at that. We have negative x squared, right? That is different than negative x squared, all right? If I have this, I square it, then I make it negative. If I have this, I make it negative, then I square it, and it would come out positive. Make sense? So I know that from this, I will get a negative number. From this, I get a positive number. So be careful with those. Because I square the 2 and get 4, and I make it negative. So I get negative 4 plus 8. So f of 2 equals 4. Easy enough? What questions you got? Good? All right, so then let's see f of 7. 7 fit in first, second, or third? Third. Because here, see, this is less than 7, but it's actually included here. So greater than or equal to 7, it's the third one. So this is the square root of 2 times 7 plus 6. So that's going to give me the square root of 14 plus 6, which is the square root of 20. Now, a skill we need in pre-cal is to simplify our square roots. And that does not mean you touch a calculator because I don't want a decimal. Okay? If the only way you know how to do it or the way you learned it was to find the largest perfect square that divides into a number, that's not the best way to do all of them. That works nicely here because it's a number we know the factors of pretty easily. But anything bigger, if you have to think of it more than a minute, then we're not going to worry about it. So to do this, okay, I can do 2 times 10 or I can do 4 times 5. But 4 is a perfect square, so I'm going to choose 4 times 5. Anytime I do a branch, I stop either when I have a perfect square or I have a prime number. So this 4, I can take the square root of 4. What's the square root of 4? 2. Ooh, sorry, my pen is weird. It's 2. And then I can't take the square root of 5, so he stays underneath. And my answer, I don't know why my pen isn't working, is 2 square roots of 5. So f of 7 equals 2 square roots of 5. You want to check yourself and make sure you're not backwards, because a lot of people would put 5 square root of 2. I don't know why, but I see that all the time. You take what's on the outside and square it, multiply by what's on the inside. So 2 squared is 4 times 5 gives me 20. So I know that it works. Okay? We good? Got to be able to simplify our square roots. Any questions at all? Okay. So when you look at this, and again, my bracket's all funky for some reason. If it helps to make yourself a little number line, make yourself a little number line. It's not that big of a deal. So I have this. I've got -4. And then, so from here, and then between -4 and -2, and then -2 on. So this is, if I numbered these, or I put them A, B, C, right? This is A, this is B, this is C. And then you can easily figure out on the number line where your numbers fall. Okay? So g of -3. What does -3 go with function A, B, or C? B, because it's between -2 and -4, right? -3 is right in here. So that means that's how I know which one to substitute it into. I'm going to substitute it into this one right here. Well, that's kind of weird. I just have an 8, right? Well, what this means is then g of x equals 8, which is y. So it just means y equals 8. That's a horizontal line. So between -4 and -2, I just have this horizontal line. So between there, no matter what x value I substitute in, I get out the y value of 8. So g of -3 is 8, and there's no work there. It's 8. Like, I don't even substitute anything in. Okay. You go ahead and find g of -8. Actually, I want to do that one together. We'll do that one together. Okay. Because I want to talk about working smarter, not harder. So -8, does that go with A, B, or C? -8 will be over here, so it goes with A. So I'm going to have 1/2 times -8 cubed plus 7. Okay, so the first thing I want you to ask yourself is, when I cube -8, whatever the number is that I get, is that positive or negative? Negative. So I know it's a negative. I'm going to go ahead and then when I take it and multiply by 1/2, that part's still negative. So I've made my decision now. Now I can ignore the sign so that I don't, do something weird. All right, so I don't want you using a calculator on this because, like I've said all along, you can do this stuff. You want to think smarter, not harder. Isn't this the same thing? And again, I'm going to ignore my negative because I already made my decision. 8 times 8 times 8, that's 8 cubed, right? And I'm going to multiply it by 1/2. You're allowed to multiply in any order. So there's no reason you have to do 8 times 8 times 8 and then take half of it. You can, but yuck, I don't want to do that either. Instead, group them this way. Half of 8 is 4. What's 8 times 8? 64. Okay, so now I got 4 times 64. Couple of ways to do that, but when you multiply anything by 4, all you have to do is double it and double it again. So if I double 64, that gives me 128, right? And so now I have 2 times 128. Well, 2 times 120 would be 240, right? 2 times 8 is 16, so I get 256. And you see how you simplify that from just like trying to multiply big numbers and having work everywhere? Make it, and the more you do this kind of stuff, the more you will see how numbers relate. So this is negative 256 plus 7. So g of negative 8 equals, what's negative 256 plus 7? Negative 249. Good. And look, calculators aren't evil. And I know when you leave here, I can't say, okay, you're not allowed to use a calculator because you're going to do whatever you want anyway. But practice with your own brain and then check yourself. Nothing wrong with using it to check yourself. Just don't use it as a crutch. Okay, I understand you want to be right, and that's one reason why you want to do it. But exercise your brain a little bit and then just double check yourself. And you'll have to be double checking yourself less and less. We good? All right, 3.1. Does that go with A, B, or C? C, because it's got to be bigger than negative 2, right? And so this is the absolute value of 3.1 minus 4. That gives me the absolute value of negative what? Yes, good. Negative 0.9. You can always think in terms of money. You gave me $3.10, but you owed me $4. You still owe me 90 cents, right? And so when I take the absolute value of that, then g of 3.1 equals 0.9. Easy enough? Questions? On delta math, you're going to have to evaluate from a graph also. So on a graph, if I say, what is g of negative 3, you find where x is negative 3, figure out what the y value is. That's all you're doing. Okay? We good? Easy enough? Any questions at all? That's it. That's all we're doing. We decided we're not going to graph with Piecewise because we do it. It makes your brain hurt. We'd rather you understand the other graphing better, and then we don't use it a whole lot, but we use the other graphing a whole lot, so we're just kind of picking and choosing what's important. All right, that's it. I did. Your assignment, you have a worksheet and you have delta math. They're both due on Thursday. So on Thursday, or before that, it doesn't matter. You're going to hand me the worksheet, and then just make sure delta math is done by then as well.